Okay. I'm going to get started. This is a pretty intense lecture. There's going to be quite a few important things that you'll learn that you'll see pretty much throughout the next 2 weeks. So hopefully you stick along with me. But essentially, this lecture is going to be about like the React lifecycle. So how components are created, how they're like updated, and then how they're dismounted, as well as hooks. And I'll get more into hooks. Well, you've actually seen one before. But yeah, so just as a quick review, when you're working with a component tree, there's 3 main motivations for when you want to break it down into like smaller components, or break a component into smaller components. So the first is if it's like getting too long, too hard to read. The code that you saw in the previous workshop could all theoretically be in the same component, but that's just not ideal. When you're working on a large code base, you want everything to have its like own purpose. So you want to split up components that, or you want to split up like large files into smaller ones so that you can work on files one at a time and like track your changes better. And an analogy is like when you're building a house, you have specific plans for each of the rooms that you're building. And in React, in the previous workshop, you don't want to add the nav bar to your app component because it serves a different purpose. The second reason, I mean, all these reasons are pretty related, but the second reason is that these parts or sections have different functionalities. So like in a shopping mall, different stores have their different like purposes. So you don't want all the stores to be in the same component. You want like a store component so that you can like treat each of them sort of like differently. And in React, comments, even though they like could be stored inside of a post component, should reside in their own component because it's more reusable, and comments have their own functionality. And the third is if your component's like handling too many responsibilities. To make your code more readable, you want each component to like do its own thing. So that, again, it's easier to track your changes. So like in React, if your button does a lot of like backend things like sends something to your server, or it has a lot of complicated logic, you want that component to be maybe separate in a different file, and then you can just like call a component inside the form. At the end of the day, it's really your choice how to design your component tree. Once you go through our workshops, you'll get a better understanding of like, or a better idea of like when you want to break up a component into smaller components or when you want to merge components together. This just takes time and practice and looking at examples of good code. So a bit of practice that I'll sort of speed through because we're running out of time. Again, state is maintained by a component, and it's a bit of memory that this, a component maintains like even after it's rendered multiple times. So think of this as something that's persisting. It's also mutable. We can mutate it using the set functions that we define when we call the useState function. And it's updated either by us when we're interacting with the website or via computers, or like when we're interacting with different computers. And states essentially give us control over displaying different things in the application and actually storing that somewhere in our code. So props are a lot more surface level in that they're just passed down between components. Think of them as like arguments to functions if our components are functions. And they're not mutable, and they only change when we update, like, for example, a state in a parent component, and it's passed down again back into a child component. That's the only time like a prop would change, if it's being changed somewhere up there. You guys just saw this. This is how we create a state. We have the value and then the setter for that value. We call useState, which is imported from React, and then we create, we give it an initial value. You guys have seen this already. So here are some examples of using our state. We want to have different states for each of the things that we care about. So persons, I guess, or people is an array. Pets is also going to be a separate array, a separate state. And then exists is going to be a Boolean. So in general, these states can take on any values. And usually our components are going to have lots of different states. So again, we never want to modify the state directly. We always want to use the setter for the state that we define when we call useState. Okay. Another thing is when we're setting an array, we usually want to do it in this way where we destructure the initial value. So let's say pets was like an array that had like 3 values. All this is doing is sort of like flattening that array or taking away those like brackets. And then once we do like this ... pets, this becomes like 3 elements within this new array. So might be confusing, but we'll see an example later tomorrow. And then here's a bit of a discussion about like where we actually want to store our states inside the component tree. If we're looking at a website, we see that there are a few common components between these different pages that we might view. So this is our feed. The feed has both a tabs component and a tweet panel component. And notice that these components are pretty much the same between different views of the website, except that on the left, we have the posts highlighted. On the right, we have the likes highlighted. And then on the left, we have the tweets, or the posts. And then on the right, we have, like, I guess, the liked posts. So what this would probably look like is in the tabs component on the top, we have some state that specifies what the selected tab is. So maybe selected tab on the left is 0, which corresponds to the 0th index in this array of the tabs, so posts. And then in the right, likes is, or the selected tab is probably set to 4, which would correspond to the likes element in the tabs. Does that make sense? And then in the tweet panel, we'd probably have like a state that stores the content type. So on the left, it would be the posts, and on the right, it would be like the liked posts. The problem is that there's no coordination between the states that I just described. If we just store the state within tabs and then store the state within tweet panel, when I make a change in tabs, like when I press a different tab, how does the tweet panel know that I want to update what type of tab I've selected? And the answer is I have to move the state from the tabs in the tweet panel up to the parent component so that the parent component can then propagate the changes down to the children components, because these states are related, right? So instead of having 2 separate states, I would just put one state, the selected tab, up into the feed. So before in code, I would probably see like a state that's content type in the tweet panel, and then a state that's selected tab in the tabs component. And afterwards, I would put sort of a combined state up into the feed called selected tab that I can then pass down into each of the children components using props. So in general, if you see that you want to have states that are sort of like connected or like interacting with each other in children components, move them up to the parent that's like some parent that's, I guess, in common for both of them. But you don't want to move it up all the way. Move it to like the least common ancestor if you've like learned some algorithms before. And then once you've moved up states to the parents, you pass back, or you pass down that state value as props to the children. And you might have to pass down the same state as props from like one child to another child to another child. if there's like a large nested structure in your component tree. So another, I guess, like to emphasize the point again, you can't share states between children components directly. You have to go through and go up to a parent component and then pass it down. I guess this is just like reiterating the point. But yeah, like let's take a look again at this Twitter page breakdown. We have lots of components. The app is the outer component. And then within the app, we have a nav bar, a feed, a trending page, and a profile component. And then within the feed, we have tweets. And within the, sorry, I guess it was suggestions, not profile. Within the suggestions component, we have profile components. And hopefully, this tree makes a bit more sense. This is the React component tree. We have the app, which has these 4 children components. And then the tweet is a child of feed. Profile is a child of suggestions. So take a moment, answer this question with the neighbors around you. Which of the following should app pass down as props to these components? Okay, bringing it back in. So the answer is we should pass down anything that might be used in like multiple components or multiple children components. So this includes blocked users, following, and followers. And here, like on these arrows, we see like which sort of props the app might want to pass down into their children. So into the feed, we'd probably want to know like which users we're following, which users we have blocked, and a list of the tweets. Into trending, we want to know our following followers. And then into suggestions, we'd probably want to know following followers, as well as blocked users, because we don't want to see them. So the reason that we don't want lists of tweets to be a prop inside, or a prop that's passed from app to feed, is because it's really only used in one place. It's only used in the feed component. And that means that we can actually just store state, or store the list of tweets as a state in feed instead of having a state in app that's passed down to feed, because none of the other children components of app need the list of tweets. Whereas for the other 3, we would want to pass it, or we would want to store it in app and then pass the same values down to the children components. I'll skip past this. Any questions so far? Sorry about that. Okay, so let's talk more about the component lifecycle. And this is how like state is managed inside of React. So you can sort of think of component rendering as a process where that's sort of like what we see in restaurants, where there's a trigger. The trigger happens when a customer orders something, or when we first want to, or the first time like a component is called, or a trigger is when one of the states in the component is changed. So after this trigger, we have the render step, which actually runs the JavaScript code in the component. So that's all the stuff like before the return statement in the component. And then it calls all the subcomponents as well that you see in the return statement. And then commit is the last step, which takes all of that JSX that we just created or that we just obtained from the return statement, and then converts it into HTML or adds it to like the DOM, which is the document object model. And then this is actually just sent to the front end or like the browser where we can actually see the end results or the HTML. So there's 3 steps: trigger, render, and commit. Trigger is like when a customer orders something. Render is when the restaurant returns like what they want to be rendered. And then commit is when we actually serve it to the client. So I have an example website, and you guys can also follow along. If you visit weblab restaurant.herokuapp.com, or I guess this website has been around for a long time. This example has been around for a long time. You can see this sort of like a very, very plain React app that has a button called Order Steak. When you click Order Steak, it presents this steak, and you're now given an option to send it back to the kitchen. Right now, it's a raw steak. I want it cooked. So I can send it back, and then it gives me a rare steak, and then I can send it back, and keep on going. And I'm actually going to run it locally as well, just so you guys can see the code. So the code looks like this. I have a state component. It has a state called doneness. Initially, it's going to be 0. And doneness is like some value that's going to be 0, 1, 2, 3, or 5, 4 or 5. And then I essentially take the steak and then render a different photo based on what the value of the state is. So I have like a list of these steaks, a list of images, and then yeah, I just render it. I have a button, I have an image. All of this is actually available to you on a branch of the skeleton code. I don't know if you have access to that yet, but I'll add a link to the slides. But yeah, so what happens when we initially press the order steak button? So when we press it, this is the first time that we see the steak component. Before, there's no steak component here. Afterwards, this is only, like, this is, the first step is the trigger, or like when we press the button, the trigger happens. And this first step is called mounting. So mounting is when it first appears for the first time. Afterwards, the code in the state component is run. So all of this JavaScript is run. And then we get the JSX. And then afterwards, for the committing, the HTML DOM is updated based on the JSX that we created. And then this is actually displayed to us on the website. So yeah, these are the different steps. And you might have noticed that we had this button, send back to kitchen, that probably looks a lot like the cat happiness button, where we just had a callback function send to kitchen that takes the previous state, adds 1, and then sets the state to that newly incremented value. Now, every time the state changes, so every time doneness changes, this triggers a re-render, and we cycle again through the steps. So this set function actually is a trigger, which leads back into the render step and then the commit step, which means that every time we click the button and we change the state, we see the updated value or an updated component rather than the old component. So this is just how React works. Every time we change a state, the component's re-rendered. Okay, so what happens when we delete the state? Well, when we press delete stake, the component goes away, and this is the part of the lifecycle called dismounting. So the opposite of mounting is dismounting, essentially when we remove it from the document object model so that the HTML no longer displays that component. So that's the end of lifecycle. Essentially, a component will go through 3 main phases. The first is mounting, where we have these trigger, render, and commit steps. Then a state change happens, and then we have another trigger, which is a state update, then the render, then the commit. And then we keep going through these state changes, and eventually the component is dismounted, at which point we're no longer going to view the component. Okay, so this is a really important hook that we're going to discuss now. It's called the useEffect hook. You've seen the useState hook, and useEffect is probably the second most popular hook that you're going to see. So hooks allow us to access different parts of the component lifecycle. We've seen that useState can update states, which trigger re-renders of our components. But sometimes useState isn't enough for us. So here's an example of, or here's a piece of code, and I'll give you a minute to read through it. And at the end, I'll ask you what this console.log is going to print. So person starts as empty. Essentially, we're setting persons to be the array that's one element, me. Who thinks that it's A? Show of hands. Who thinks it's B? More hands. So the answer is actually A. And this is really undesired behavior because we really want it so that we can access the new value of persons after we've done a set state. So it's kind of counterintuitive, right? Like we've just set the value of persons to be the array me, but once we log the value of that state, we're left with the old value and not the new value. And this is where we want to use the useEffect hook. And essentially, useEffect is useful because we can do some behavior after a state has changed. And this is just one use of the useEffect hook. So yeah, we run some function after a specific variable changes, and this variable is usually like a state in our component. And you'll see a bit of this later, but commonly this is used to like do some complicated functionality that's external to React whenever some state changes. And the syntax is this. We have useEffect that takes in two arguments. The first is a function. This can be like a callback function. And the second is a dependency array. It's going to be literally an array. And this is optional, so we can either have a dependency array or just have one argument being the function. And if we do have the dependency array, then this useEffect tells us that whenever anything inside this array changes, we call this function. Okay, so for example, we have this callback function, or we have this function myFunction that does something, and then we have three useEffects here that all look sort of different based on because of the dependency array. So this first useEffect, and let's assume that var1 and var2 are states. myFunction is called both after the initial render and after either var1 or var2 is changed. And this is a pretty common use of useEffect. I think this is probably the first or second most common case of useEffect that you might be using. If this dependency array is empty, myFunction is only going to be called on the first render or upon mounting. So notice whenever a dependency array is specified, this myFunction will be called upon mount. And then if you do have something within the dependency array, myFunction will also be called whenever one of those values changes. And then the third case is if we have no dependency array. And this actually changes, or this calls myFunction at every single re-render. So the first time as well as when any other state changes. So this is just like, it always changes. Usually you won't see it a lot because you usually want some functionality or some function to call only when you change a specific state. So you're really only going to see like the first two cases the most often. Okay, any questions about these three uses of useEffect? All right, so now, instead of having the code from before, where we try to console log persons right after we do the set, we can have a useEffect that takes in persons, the state, as a dependency, so that anytime persons changes, the function that's the first argument of the useEffect, which is this callback function, is called. So if we called the function testing stuff, it would change persons because it adds me to the end of it. And then it would, the useEffect would run because it sees that persons has changed, and then the console.log function would be called. At this point, because it has the updated value of persons, because it knows that it has changed. Console.log persons is going to print the new value, which is the array with me at the end. And then one more thing with the callback function that you pass into useEffect. My computer died. Yeah. It's weird. Like 30 something.
Oh, no.
Sorry about that. So if you pass a function that has a return statement at the end, the function at the end is actually going to be run whenever the component dismounts. So you can think of it as a cleanup function. Usually, it's going to do something like disconnect from an external service if at the beginning of the render, when you first mounted, you did connect to it. We'll see an example of this return callback function being used in a bit. And this step deals with the dismount part of the lifecycle. Okay. Any questions? I know this is pretty fast. Any questions about like how useEffect works? Okay. Here's some common patterns in React that you might see. That's just, oh yeah. Good. Yeah, so the question is like, how did useEffect solve the problem where like after we set persons, like we couldn't see the updated value? Yeah, essentially like set persons is kind of has like, you're not exactly sure like how long it'll take, / it doesn't run immediately. And because of that, like when we call set persons and then immediately after try to log like the thing that we supposedly just updated, it's not going to have the most updated version. Whereas if we call set persons and then have a useEffect that specifically looks at like whenever the person's state changes, then this is going to recognize, oh, once it changes, I'll have the new value, so then I can log the new value here. Yeah. Oh yeah, so persons sort of just like flattens or like takes the elements of persons and like removes like the array around it, sort of. Yeah, so like the end result is going to be like still a full array of like all the people. It's not going to be like one array and then a string or something. Okay. Yeah. So one thing that you might see a lot is conditional rendering. So in JSX, we're pretty much like using quote unquote HTML tags to render stuff. And we can sort of put these elements or reference these elements using these curly braces to escape out of like JSX. So if we're returning this div and we want to have like both the header and the content show up, even though these are JSX elements, we can still like sort of insert them into this div by using these curly braces. Right. So take a minute to guess or sort of, I think you guys have seen this conditional rendering, but just take a minute to talk to the person around you. What is this code doing? Like, based on the value of loading, which is either true or false, what will it display? Hopefully you know it. When loading is true, it's going to display the first part, so everything between these two parentheses. And then when loading is false, it'll display everything between the next set of parentheses. And this is a common structure that you'll see a lot. We'll have this like conditional rendering that uses a ternary statement where we have a condition that's going to evaluate to either true or false, and then a question mark, and between this question mark and the colon is going to be what we want to render or return if the result is true, if this condition is true, and then what we want to render if the condition is false after the colon. Let's get past that. Another thing you might want to do a lot is render an array of data. A lot of the time you'll have a state that has that's like an array of data, perhaps like a drop-down menu, like selections for that, or a list of data items in a database. You can use the map function that we talked about in the morning to map elements in arrays to, I guess a quick review of map. Map like takes an element in an array, or it takes an array and then receives a callback function that takes an element of the array and then returns something else. So we saw in the morning that we could do like Celsius to Fahrenheit and then map all of these Celsius values to Fahrenheit values by passing in a callback function that takes a Celsius value and returns the Fahrenheit value. So we can do the same thing or use the same idea to map arrays that might not be like renderable in React to things that are actually renderable in React, essentially JSX elements like divs. So if we create a callback function that takes like an element of an array like this, that's sort of an object, and puts the item name in a div, and I guess returns like a div with the name inside, then we can map the entire array to this array of like divs using the map function. So this would look like something like this, where we have data, which is an array of objects. And then we have this callback function that takes an element of this array and maps it to, or returns a div that uses like the the items inside the object. And we pass that callback function into this map function. And we call data.map with the callback function as the argument. And all this code is essentially the same thing as if we just returned two divs that looked like this. And the top code is just a lot more concise and yeah, easy to understand. / you can update the data and then you don't have to change like the return here. All you need to do is like add elements to the actual data state. And that makes it so that you don't have to like actually create new divs every time your data array changes. And a quick note about this key. The key is used, I think. Maybe it's not here, but the key makes it so that if you have like a unique key, React recognizes, it helps React like prevent unnecessary re-renders. I guess you don't have to worry about it too much, but you might see it in future workshops. Try to make it so that all your components inside, all your like JSOX elements inside a component have different keys, especially when they're like very similar elements like comments or like divs and stuff. So yeah, as a quick exercise, like what would this code look like if we tried to write it without the map? It's pretty much the same thing as before, or the previous slide. It would essentially look the same as if we had two item components with the text passed into here. But instead, we use map so that we can reuse the same like logic. And that way, we don't have to write out each of these different components. We can just take an array with like values that we might more commonly use and then map it to these JSOX components. And then finally, you might see a lot of like fetching and sending data from a server, but we'll see more of this tomorrow. And a few minutes just for questions. I think we're running out of time, so the rest of this lecture will be moved to tomorrow morning. Any questions about maybe those last two parts, like conditional rendering / mapping in JavaScript? Okay, if not, Abby will give some announcements. So today's really going to be a lot of recap about React. We're going to start with components, looking at like the use state hook. Then we're going to talk about a new concept called the React Virtual DOM. And that leads us into the component lifecycle. I think I referenced the DOM yesterday while explaining the component lifecycle. I realized I probably should have talked about it before because it's quite important to know in order to have the proper context for the component lifecycle. And then finally, we'll look one more time at useEffect. And then to combine all of the knowledge that we learn, we're going to walk through an example of creating a React app from scratch. And we'll implement a simple timer that uses useState, useEffect, and then has like nested components. Everything that you might see in a standard app will be in that in the app that we create, hopefully. So a quick recap about React components. Essentially, at a very surface level, component is a very powerful HTML element. You've seen HTML elements before on day one. We can have like buttons, encloses the text click me, and it's going to look something like that. And in React, to create a button in our UI, it's going to be very similar. The way we do it is we create a function called whatever we want, like button, that at the end returns some element. And this eventually renders into the same thing that we would see if we did it in HTML. So let's analyze the components of a component again. First, I really want to emphasize that components are JavaScript functions. They're not classes. If you ever search up React documentation online, you're probably going to get a lot of conflicting feedback about like what components are supposed to look like. In old React, components used to be defined as classes. So it would be like class button extends React component or something like that. Nowadays, components are always going to be functions, and it just makes React much faster, and it's really just the standard now. And it doesn't matter if you use like a callback in the way that this is being defined, or if you do something like function button with the open and close parentheses. It's going to mean the same thing. And then the other key part is that components use JSX, which is similar to HTML, but it's not exactly HTML. One key difference that you might have seen before was that like instead of class, you use class name. And then also inside JSX, you can escape and have JavaScript code, whereas in HTML, you can't really do the exact same thing. And then components are powerful because within the component, between declaring it and then telling it what to render, we can have a lot of complex logic. The most common piece of logic that you'll see is storing state. State is like a piece of memory that resides within a component. And after renders, state persists. So that makes it so that we can have like a consistent piece of memory that we can do other stuff with, for example, using the useEffect hook that we saw yesterday. And this is something that HTML just like really struggles to do. It's very, very complicated to like have state in HTML. And yeah, this is one of the main like reasons why React is so powerful. So looking at the useState hook, hopefully you're familiar with this by now. We have the state declared here. We have the state set function declared here. This is an array with 2 elements. And useState with an initial value, with whatever you want it to be, evaluates to an array with 2 elements, where the first one's the state, the second one's the set function. So this is how you create a state in React. And now let's take a look at the bottom of the component where we return. So components are always going to be made up of JSX elements, which are pretty much like the HTML elements, as well as other components. Only these 2 types. So what this means is that if you sort of think of like a component being a parent, and then its children are all of the elements that are rendered by it, all of its children are either going to be JSX elements and components. So recursively, if you go all the way down a tree, eventually all the leaves should be JSX elements. You shouldn't have any components in the leaves. And yeah, so React is really powerful because you can nest components within other components. In this simple example, we have like the button that we saw before being nested inside a form. And to render the form, what we do is we first render this JSX element, which is a header that just looks like that. And then we recursively render any components inside this component. So we recursively render button, and button renders as just a JSX element that's button, so it looks like that. And the key thing to remember is these components are all functions. So when we render something, essentially all we're doing is running the function that defines the component. So when we render form, we're running this entire function, and at the end we're returning a value. But to determine like what this value actually is, we have to resolve what the value of button is. And then going to the definition for button, we have another function that we run or call, and then we get a return value for that. And then we get that return value and place it where this is. And then we keep propagating up until we can get a full return value that's not consisting of any components and only JSX elements. Any questions so far? Okay. So remembering this nesting structure, let's now visit the React virtual DOM. Previously, we've seen React component trees, which is like a tree structure that shows the relationships between parent and children components. And notice that this tree doesn't have any JSX elements. And that's just because we usually only care about the relationships between components, because between components, we're passing down props. And that's where a lot of our logic in the app is going to be in. We don't care a lot about passing down props or I guess passing down values into JSX elements, because usually that's a lot more surface level. So our component trees are going to be all components. Whereas React's virtual DOMs are going to be different, where it's going to be all JSX elements. And we'll see that in a bit. Let me first explain what a DOM is. It's a document object model. The way to remember is it's a model that shows or represents the objects that comprise of a document. So what is a document? Well, a document in the context that we're speaking in is just like the website that you see or the web page that you see. So this is probably like an HTML, like if I open Google, for example, this is a website, and all these HTML elements can be represented using a DOM format. At the very top, we have the document, and then we have the HTML root element, and then we have head and body, as we saw before, and then head is title, and so on. And we can sort of more cleanly represent this as a tree like this. The DOM isn't exactly the same as HTML. DOM is just, I think, like a more general sort of data structure. But you can use DOM to represent HTML. And similarly, you can use DOM to represent your React components. So React creates a virtual DOM of all of your components whenever it renders to the website or to the browser. So virtual DOM is virtual because React uses it internally. It's not exactly the same DOM that gets displayed on the browser. The browser has its own DOM. But we'll see why React wants to keep track of its own DOM, or its own virtual DOM, in 3 sections. So to create the virtual DOM, essentially just recursively renders each component from the root, and then let's say component X has these JSX elements, but then also calls or has this component A nested in it. Then component A probably resolves into these 5 JSX elements. And that's how we get this virtual DOM for the component X. OK, so hopefully that's enough context now for us to talk about the component lifecycle. There are 3 steps, or 3 phases. The first is mounting, the second is updating, and then the third is dismounting. So think of it sort of as the first and third steps are opposites of each other, and then the second step is a phase where we're just sort of in a limbo and repeating. Sometimes you'll see dismounting called unmounting online. But yeah, so mounting is the process of adding a component to the DOM, or the virtual DOM. So let's say our virtual DOM initially looks like this. Mounting is the phase where we add a component, let's say component A, to the virtual DOM so that it now looks like this. And then updating is whenever we still have the component, it's not gone yet from the virtual DOM, but we change parts of it. And these are caused by triggers, which cause re-renders, which cause the virtual DOM to change for that component, which causes the entire virtual DOM to change. So this is usually when, or the phase that our components usually stay in. Oftentimes we have a state that changes within a component, and every time we change the state, it's not like the component's dismounted and then mounted again. It's just updated. And React does that so it doesn't have to like do all the work of dismounting, mounting, dismounting, mounting every time a state or a prop changes. And then the last step is dismounting, which is when it actually is removed from the React virtual DOM. Okay. So I want you to take a minute to visit this website again, weblab-restaurant.herokuapp.com, and I'll pull it up. And see if you can like identify the places where a component's being mounted, where it's in the updating phase, and then where it's being dismounted. So for the sake of time, I'll just go through it. So to help me, I guess, provide evidence that it's actually being mounted / dismounted, I'm going to right-click and then press inspect and then go to elements. This shows us the browser's HTML that it's rendering. And I'm going to expand this div so that we can see all of the inner components, or the inner elements. Okay, so now I'm going to press the order stake button. And notice that this div appeared. This div wasn't here earlier. And this is probably indicative that the component that this is being rendered by just got mounted. And it just got added to the DOM, which is why it's showing up in the HTML file. So pressing this button triggered the mounting phase. And then now when I press this new button inside the component, my guess is that a state is changing within the component, which is causing the component to be in the update phase. So it's re-rendering every time I press this button. And then finally, when I press delete stake, notice that this div is going to disappear. And this is pretty good evidence that now that component was just dismounted. And actually, yeah, I'll just leave it at that. Any questions about that? Okay. So I have a question. There's a word that I'm looking for, but does anyone know what causes a component to enter a different phase? There's a word that was brought up yesterday. Yes. Yeah, exactly. So the term that we use to like describe all the events that cause the component to enter a phase is triggers. And these are the most common triggers that you're going to see. So the first is whenever you open up a website, React is going to tell you to like render the root element, which is usually like app or something, and then it renders all of its children, which renders, so like all the components render in the very beginning, and that's called the initial render. And that's when a trigger is going to happen because a lot of these components are being mounted. And then another case is when one of its ancestors re-renders. And we saw this with form and button, where button was a child of form. Whenever one of your ancestor re-renders, all of its children are going to re-render, and then all of their children are going to re-render. So eventually, if it's your ancestor, then you're going to also re-render. Now, there are ways of avoiding this. As you might suspect, this is pretty expensive. If we just wanted to change like a state inside the app component, that would mean that we would have to like change all of the children components, which seems pretty expensive, not good for responsiveness and stuff. So in the future, we'll see different callback functions, or sorry, not callback functions, different hooks that can be used so that we don't have to re-render every time an ancestor changes. And the two most common things that you'll see, at least in the scope of like an individual component, is that when one of its states changes, it's going to re-render. This is going to be a trigger for re-rendering, as well as when a prop that's passed from a parent to the child changes, or from a parent to itself changes, then it's also going to re-render. A lot of the times, these cases are the same because a lot of the times from parents, you're passing down states of the parent as props. So when the state of a parent changes, that causes the parent to re-render, which causes you to re-render, which is the same thing as when, or it happens at the same time as the prop changing because the prop was the state that was being passed down. Okay. So what's the term for creating the virtual DOM at each phase? Does anyone know this? I've said it a lot of times in the lecture. It's yeah, like re-rendering or rendering. I guess the question wasn't too clear, but yeah, like rendering is just essentially running the functions or running the components and creating all of the JSX elements that it's comprised of. So we've looked at rendering before, but just again, if we have this sort of, this is like a component tree. If we suppose that a state and inspiration generator, this component changes, that's a trigger that causes this component to re-render. Specifically, we look at the state where, or we look at the component where the state resides. We don't go up all the way into the tree to re-render the entire app. That's too expensive. So React looks at where the state resides so that we can render or re-render as little as possible. So we see that the state resides in inspiration generator. And then because its children are here, they need to be re-rendered as well. So that's a trigger for them to re-render. And yeah, I think we've seen this a lot. And last question, there's one more keyword for when React transfers the virtual DOM to our browser. Does anyone know what this is? Yeah. Close. Or serving, yeah. It's similar to that. I think it's like the same meaning. It's synonymous. Anyone? It's committing. Yeah, so committing is just like, essentially it's taking the diff, and hopefully this diagram helps. It looks at the real DOM, which is owned by the browser. So Chrome owns like its own DOM, which it uses to like show the HTML or create the HTML. And then React has its virtual DOM. And these are like the JSX elements or whatever. But you can see them side by side and compare them. And during the commit step, React will look at the difference between these two DOMs and then identify the difference or the places where they're different. And all of the places where they're different is called the diff. And then React is pretty smart. It knows that all it has to do is only modify the parts where it's different. So it's only going to modify the real DOM objects inside the diff to have the new updated values. So if this was the old real DOM, the new real DOM will just reflect whatever the virtual DOM is. And this concludes the last step of like React sending stuff to the browser, or like rendering stuff. And then once the real DOM changes, there's a last step called painting, which the browser does, which converts this real DOM to HTML. But that's not too important. So the takeaway is that we can sort of look at the component's lifecycle as 3 phases: mounting, updating, and dismounting. And then these transitions are marked by 3 steps. Something happens, which is the trigger, which causes the re-render, which creates the React DOM. And then React takes the React DOM, compares it with the real DOM, and then commits the changes, essentially, to the real DOM. So between every transition, we see a trigger, render, and commit. But at a broader level, we have these 3 phases. Does that clear up some confusions about the lifecycle from yesterday? Any questions? Okay. And then really quick recap of useEffect. useEffect takes in 2 arguments, or useEffect, in broad terms, is a hook that does something when an event occurs. And we usually place it at the top of an element, underneath useState, but above everything else. But yeah, a useEffect takes 2 arguments, the first being a callback function, and the second being a dependency array that's optional. And I've changed these, like, the terminologies here, but hopefully this makes more sense now that we know the lifecycle. But for this useEffect, where we have a dependency array of 2 states, var1 and var2, this callback function, my function, is called on the mount of the component, as well as every time the states var1 and var2 change. Essentially, on every render or re-render where var1 and var2 have changed. And the second use of useEffect, where we only want it to happen on mounts, is just passing in an empty dependency array, which means that this function is only called once at the very first render. And then if we don't pass in any dependency array, this means that this function, my function, is going to be called every time the component re-renders. Okay, any questions about useEffect? And we'll play around with it. I will skip past this. Essentially, useEffect is quite useful because suppose that we have like a lot of complex code that we want to execute only once a component is mounted, like the first time. We could just use useEffect, and then what type of dependency array would we want to pass it if we want it to only happen once upon mount? Anyone? Yeah, exactly. We would use an empty dependency array so that all of the hard work is done only on the first mount. Another reason why it's useful is because, as we saw in the example from yesterday, like set functions for states aren't exactly like intuitive because they don't happen right after they're called. So if we do this, where we like append a value to the end of an array, the state's not actually going to be updated. It's not going to have me at the end. So the better way to do it is have a useEffect that takes persons as a dependency and then do some functionality with that. Okay, I think I can run through this in 10 minutes. Okay, hopefully this is helpful, but I wanted to show you guys how to create a blank React app because you guys have like you guys have seen the workshop code, but you don't, you might not know exactly where it came from. And 1 second. I'm just going to change the screens. Okay, So I'm just going to do it on my end. You don't need to follow along. It's probably better if you don't follow along so you can actually see what's going on. But I'm going to create a blank React app and then implement a stopwatch that looks like this, where we can toggle the clock and then the time just runs every 1 second in increments. And this will use useState, useEffect, everything that we learn. So in my terminal, I'm just going to create or run the command sorry, 1 second. Okay. Here, okay, there we go. So in my terminal, I'm going to run npm create vite at latest. Oh. Okay, can you guys see it? Okay, so in some random directory, I'm running npm create vite at latest. Vite helps us create React apps. Project name, I'm just going to call it test2. Select a framework. I want to use React. I'll use a standard JavaScript React project. And then now, if I look at my directory, I see test2. So I'm going to change directory into it. I see that it's populated with a lot of files. That's great. And then I'm just going to open up the code now. You guys see that? Okay, so I'll open up a terminal. First step, whenever you create a new project, is to run npm install. You guys already did that with Catbook, so you probably don't need to for a long time. In the meantime, I'm going to open up app.jsx and main.jsx. And what's really important to see is that in main, actually, even higher up, I'm going to go to index.html. So anytime you create a React app, essentially it's serving an HTML file as well as lots of JavaScript files to define how to manipulate that HTML file. And it's so abstracted that the only JavaScript file we're passing is main.jsx into this HTML file. Now that I've installed, I'm going to run npm run dev. And then in my localhost 5173, I should be able to see this blank React app. But yeah, so if I right-click here and then look at the HTML, I can actually see that this is the same exact index.html that I'm sending over, that I have in my code base here. It has the same source equals source main.jsx. So this tells us that all of the React logic is being somehow taken from main.jsx and then put into this HTML file. So how exactly is it doing it? It's taking, or React takes the document and then finds the ID, or the element with the ID root. And if we look here in the HTML here, the div that's the innermost div for body is actually the one with ID root. So what that means is React is creating a root within that div by finding the div and then rendering the app component. So this is the connection point between React and HTML. You don't actually have to deal with this a lot, or actually ever. Once you know this, you can comfortably understand, like, okay, I know that my app is being rendered, so all I have to do is change how app is implemented, and then I can render whatever I want on the website. So that's what's happening right now. We have all this code here that I'm just going to get rid of. I'm also going to get rid of the CSS. I'm going to create a very simple timer. And I'll just put it inside app. First step is going to be having a time state. Sorry, maybe I shouldn't do this. Let me create a new file called stopwatch.jsx. Inside here, to define a component, I just say const stopwatch equals a callback function. Inside this callback function, I'm going to have some JSX. And then at the end of the file, I have to export default stopwatch. Sorry, this is so fast. But here, to render stopwatch, I'm just going to go import stopwatch from the same directory, and then I'm going to return stopwatch. OK, so if I refresh this page now, I see hi, which is great. Let me get rid of this the CSS inside main. But yeah, what I eventually want is this. I won't implement the toggle for now. I'm just going to implement the stopwatch. And the first step is to create a state for the time, because this time is going to be displayed to the UI. So const time set time equals use state. And then the initial value is 0, so I put a 0 here. It's yelling at me because it doesn't know what use state is, so import use state. And then I always just press the first option because it usually does it fine. So what I want to happen is on the first render, it starts incrementing the time. Now there's two ways to do this, and I'll show you the fast way to do it. I'm going to use the useEffect, or first off, let me just like render time. If you see here, it's just always going to be 0 because we're not actually setting it. But now let's create a useEffect. So the first argument is a callback function. And the second argument is a dependency array. I'll import useEffect. Oh, thanks. Yeah. Okay. So yeah, I have a useEffect, and I'm going to use time as the dependency. And this is a function that you haven't seen before, or you probably haven't seen before. It's set interval, and it takes in a callback as well as a time. And essentially all it does is like it runs this callback after this number of milliseconds. So inside here, if I did like console.log hi or whatever, it would like print this after 1,000 milliseconds or 1 second. But yeah, inside of the set interval, I want to somehow update my time or increment my time. And to do that, I have to use my set time. I can't just do time plus plus or something. I do set time and then time plus 1, because I take the old value, add 1 to it, and then set that to be the new state value. So if I do this now, the timer is working fine. To explain what this is doing again, I have a state that's initialized to 0. So when I refresh the page, it's going to start at 0. And then every time time is changed, as well as on the first mount, or the first render, this callback function is run. And this callback function runs, or calls setInterval, which after 1 second runs this callback function, which sets the time to 1 more than it used to be. So on the first render, time is going to be 0. It's going to run this callback function immediately because it just mounted. And then it's going to wait 1 second and then set time to 0 plus 1, or 1. And at that point, because time has changed to 1 now, the component's going to re-render because one of its states has changed. And the useEffect sees that one of its dependencies, time, has changed from 0 to 1, which then runs this callback function again. And then it sets time to 2. And then it sees the time has changed again, so it sets time to 3, and so on, every time with 1,000 milliseconds between it. Which is why we see the timer incrementing by 1 every 1 second. OK, I've run over. Any questions about this, though? OK, cool. I guess I don't have a slide for it, but you can look at the completed code here. This uses a different implementation. And you can also read the recap. I guess this entire lecture was a recap. Yeah, if you want to fill out weblab.is/feedback, that'd be great. And then we'll get started with workshop 2.